Welcome back with another video on TryHackMe.com. This is Zaheen Nazir and we are doing intro to Docker today. It will take 35 minutes and it is easy, and description is learn to create, build and deploy a Docker container. So I already started my attack box, and I know that the practice is on the last task, which is task 7. So we'll wait until we reach to task 7 before we do anything. But if there is any command or something that we need to run on the attack box, we'll run it during the tasks. So let's get into it. Task 1, introduction. Okay. In this room, you will get your first hands-on experience deploying and interactive in Docker. So, oh yeah, it's a practical guide. So, awesome. Namely, by the end of the room, you will be familiar with the following: the basic syntax to get you started with Docker, running and deploying your first Docker container, understanding how Docker containers are distributed, using images, creating your own image using a Docker file, how Docker files are used to build containers, using Docker Compose to orchestrate multiple containers, applying the knowledge gained from room into the practical element at the end. So the practical element will be the last task, as they have stated here. Please note, it is strongly recommended that you are at least familiar with basic Linux syntax such as running commands, moving files, familiarity with how the file system structure looks. Yes, we have pretty much. This is what were doing pretty much in every task on TryHackMe. But if you don't know, you can just click on the fundamental module and try to learn from here. Maybe I will cover this room in a later video. I have done it already, but I will still cover it in a later video. Alright, so additionally, it is important to remember that you will need internet connectivity to pull Docker images. If you are a free user and wish to practice the commands in this room, you will need to do this in your own environment. So we'll use the attack box. It will be sufficient to do everything on attack box. Task 2, awesome, already. Basic Docker syntax. Docker can seem overwhelming at first, however, the commands are pretty intuitive, and with a bit of practice, you will be a Docker wizard in no time. Awesome, that is awesome. The syntax for Docker can be categorized into 4 main groups: running a container, managing and inspecting containers, managing Docker images, Docker daemons, stats, and information. Okay, we'll break down each of these categories in the task. Okay, managing Docker images, Docker pull. Before we can run a Docker container, we will first need an image. Recall that introduction to containerization room that the images are instructions for what a container should execute. And there's no use running a container that does nothing, obviously. In this room, we will use the Nginx. It is Nginx, but we say it Nginx. Okay. Image to run a web server within a container. Before downloading the image, let's break down the commands and syntax required to download an image. Image can be downloaded using the Docker pull command and providing name of the image. For example, Docker pull Nginx. Docker must know where to get this image, such as from a repository, which we will come onto in a later task. Continuing with our example above, let's download this Nginx image. So this is how they are saying it should be downloaded. Download pull Nginx using default tag latest. Okay, so let's try to run this command. Right, let's see what happens here. I will move it along. This is my attack box. I click on the terminal. Let's see if we have Docker at least. Then I pull, and then the image name is Nginx. So it is already connected to internet and it is pulling the image. As you can see, I downloaded the Nginx latest image and the download is complete. Awesome. By running this command, we are downloading the latest version of the image titled Nginx. Images have these labels called tags. These tags are used to refer to variation of an image. For example, an image can have the same name but different tags to indicate a different version. I have provided an example of how tags are used within the table below. Okay, so let's see. Docker image Ubuntu tag is latest admin, the latest build that is available. Docker pull Ubuntu is the same as Docker pull Ubuntu latest. Okay, so if you don't put anything after the image name, it will always take the latest. As you can see here, this command will pull the latest version of the Ubuntu image. If no tag is specified, Docker will assume you want the latest version if no tag is specified. It is worth remembering that you do not always want the latest. This image is quite literally the latest in the sense it will have the most recent changes. This could either fix or break your container, of course. Ubuntu 22.04 Docker pull Ubuntu and then colon and then 22.04, and this will basically pull the 22.04 jammy version of the Ubuntu. 20.04 will pull the Fogel version, and 18.04 will pull the Bionic version of the Ubuntu here. When specifying a tag, you must include a colon between the image name and tag. For example, Ubuntu 22.04, which is image and colon and then the tag. Don't forget about tags. We will return to these in a future task. No worries, we will remember it. Docker image XYZ. Docker image command with the appropriate option allow us to manage the image on our local system. To list the available option, we can simply do docker image to see what we can do. I have this for you in the terminal below. Apologies, guys. Docker image, and then we have build, history, import, inspect, load, ls, prune, which is remove unused images, pull, push, rm, which is remove one or more images, save, and then there is a tag. Okay, in this room we are only going to cover the following options for a Docker image. For Docker images pull, we have done this above. Yeah, we have done this as well on our attack box. ls, list images. Rm, remove an image. Build, you will come onto this in the building your first container task. Okay, Docker image ls. This command allows us to list all images stored on the local system. Okay, we can use this command to verify if an image has been downloaded correctly and to view a little bit more information about it, such as the tag, when the image was created, and the size of the image. So let's run this. Docker image ls. Oh, we have a lot of it. Wait a moment. Let me increase the width and possibly size as well. Hopefully this is visible to you now. So we have Nginx, which is latest version 88 MB 3 weeks ago. We just did that now. Okay, created 3 weeks ago. I mean the latest version was created 3 weeks ago, but we downloaded and it is there in our system. We have mapping CyberChef latest version 140 MB. Rust scan alert, reverse shell generator, Remux, Rust scan again, then BS security empire, M mapping cipher chef, and there is something fnycol uhttpd, which is 10 years ago, which was created 10 years ago. So okay, let's continue. For example, in the terminal above, we can see some information for 2 images on the system. Repository tag image id created and size Ubuntu, which is 22.04. And this is the image id created 10 days ago and size 77. Same with the Nginx latest id 2 weeks ago and 142 MB. Docker image remove. If you want to remove an image from the system, you can use docker image remove rm along with the name or image ID. In the following example, I will remove the Ubuntu image with the tag 22.04. My command will be like this. Do we have Ubuntu image? We don't have Ubuntu image. So let's run this command anyway. Let's see what is the result. If the image is not there and we're still trying to remove it, no such image is there. So for us, there is no such image. But for the CM Natic, who was performing this documentation, for him it was available and it is removed, as you can see here. If we were to run a Docker image ls, we would see the image is no longer listed. Okay. If you answer the question, if you wanted to pull a Docker image, what would our command look like? Docker pull. Right? Yeah. If we want to release all images on a device running Docker, what would our command look like? All images, right? So it is Docker image ls. Correct. Let's say we wanted to pull the image TryHackMe, no quotation. What would our command look like? So it will be Docker pull TryHackMe. Let's say we wanted to pull the image TryHackMe with the tag 1337, no quotation. What would our command look like? Okay. So Docker image Docker pull TryHackMe and then colon and 1337, which is tag name. It should work fine. Awesome. Let's move to task 3 then. Okay. A lot of theory, man. A lot of theory. Running your first container. A Docker run command creates running container from images. This is where commands from the Docker file as well as our own input at runtime are run. Because of this, this must be some of the first syntax you learn. The command works in the following: Docker run options, image name, command, and arguments. The options enclosed in the brackets are not required for a container to run. Docker container can be run with various options depending on how we will use the container. This talk will explain some of the most common options that you may want to use. Sure. First, simply running a container. Let's recall the syntax required to run a container, which is Docker run, and then the image name, basically, then commands and arguments and options between run and image name. In example, I am going to configure the container to run an image named hello world interactively by providing the -it switch in the options command. This will allow us to interact with the container directly. Awesome. I am going to spawn a shell within the container by providing the bin bash as the command part. This argument is where you will place what command you want to run within the container, such as a file, application, or a shell. So it could be a file, an application that is present on the container, or file that is present on the container, or a shell. So achieve this above. To achieve the above, my command will look like the following: Docker run it hello world and bin bash. So let's try to run this one. So what was Docker? And then run, then it, and then I'll give the image name, which is hello world, and then you need to mention the command. Hello world is the image name, the bin bash is command. So let me provide bin bash / bin bash, and I press enter. It is saying hello world latest unable to find an image. Pull access denied for the hello world repository does not exist or may require Docker login denied request. So it is saying denied request, man. Okay, let's continue. Maybe we'll do something on in the practical side. We can verify that we have successfully launched a shell because our prompt will change to another user account and hostname, as you can see here. The hostname of the container is the container ID, which can be found by using docker ps. For example, in the terminal above, our username and passwords are root at, and this is username and hostname. This is the username and the hostname is this one. Okay, running container continued. As previously mentioned, Docker containers can be run with various options. The purpose of container and the instruction set in a Docker file will come onto this in a later task, determines what options we need to run the container with. To start, I have put some of the most common options you may need to run your container, Docker container, into the table below. Okay. Options, we have explanation and then relevant Docker file instructions and example. There are a lot of it, so let's get into it. Dash D, this argument tells the container to start in a detached mode. This means that the container will run in the background. Relevant Docker file instruction is nothing. And examples, Docker run dash D and hello world. Okay. IT, this means the argument has two parts. The I means run interactively, and T tells Docker to run a shell within the container. We would use this option if we wish to interact with the container directly once it's run. Okay, so this is Docker run dash IT and hello world v dash v. The argument is short for volume and tells Docker to mount a directory or file from the host operating systems to a location within the container. The location these files get stored is defined in the Docker file. So this is Docker run dash v, which is volume, and this is the volume host OS directory where the Docker is running, and container directory, the directory which will be exposed within the Docker itself, and then the image name itself. Okay. Dash B, the argument tells Docker to bind a port on the host operating system to a port that is being exposed in the container. You would use this instruction if you are running an application or service such as a web server in the container and wish to access the application service by navigating to the IP address. So this is expose Docker run dash p 8080 and then the web server itself. RM, this argument tells Docker to remove container once container finishes running whatever it has been instructed to. So this is Docker run dash dash rm hello world. That means it will remove this container, and if it is running, it will also finish all the running tasks. Dash dash name, this argument let us give a friendly memorable name to the container. When a container is run without this option, the name is two random words. We can use this option to name a container after the application the container is running. Okay, Docker run dash dash name, and name will be hello world. Okay. These are just some arguments we can provide when running a container. Again, most arguments we need to run will be determined by how container is built. However, arguments such as dash dash rm and dash dash name will instruct Docker on how to run the container. Other arguments include but are not limited to. Okay, telling Docker what network adapter the container should use, what capability the container should have access to. This is covered in the Docker rodeo. Room on the TryHackMe, storing a value into a environment variable. Okay, so if you want, you can just go to the Docker rodeo and try to do that, but they are saying it will take 0 minute. I don't think so. It will take a lot of practice. As you can see, it have like 14 tasks. Let me refresh it. So okay, If you wish to explore more of these arguments, I highly suggest reading the Docker run documentation. You click on it and try to go through the documentation. List running containers. To list running containers, we can use the docker ps command. This command will list containers that are currently running, like so. Let's try that. Docker ps. Oh, we have two running already. One is on ports 7777 Tetra 7. The other one is 7778. Reverse shell generator, and then we have mapping cyber chef. This command will also show information about the container, including container ID, what command is the container running, what was the container created, when was the container created, how long has container been running, what ports are mapped, the name of the container itself. To list all containers, even stopped, you can use docker ps-a. So it will list down all the containers that are even in the stopped stage. Okay. What would our command look like if we wanted to run a container interactively? So docker run -it, I think. Yahoo! What would our command look like if we wanted to run a container in detached mode? -d command. Docker run -d. This is detached mode. Let's say we want to run a container that will run and bind a web server on port 80. What would our command look like? Let's say the container that will run. So bind is -b, right? Docker run -b and port 80 colon 80. Okay, what is the hint? -p command, not b. Port binding. Awesome. How would we list all the running containers? All the running containers you can just list with docker ls. Docker ls, right? Docker ps, sorry. Docker ps. All the running container, not the list itself. Now, how would we list all containers, including the stopped one? Not sure. Dash ps dash a. This was the command. Yeah, ps dash a. Here we go. Awesome, awesome, awesome. So now we are moving to the intro to Docker files itself. This will be the last task for today. Once we come back, we will start the task 5. Okay. Intro to Docker files. The Docker files play an essential role in the Docker. Docker files is a formatted text file which essentially serves as an instruction manual for what Docker containers should do and ultimately assembles a Docker image. You use Docker files to contain the commands the container should execute when it is built. To get started with the Docker files, we need to know some basic syntax and instructions. Docker files are formatted in the following way. Instructions argument. First, let's cover some essential instructions. From this instruction, set a build-up stage for the container as well as setting the base image operating system. All Docker files must start with this. So it will be from Ubuntu, from and then the image that you want to use. So this will be the first line. Run. This instruction will execute command in the container within a new layer. Run and who am I? This will create a new layer on top of the base and then run it. Okay. Copy. This instruction copies the file from local system to the working directory in the container. The syntax is similar to the cp command, which is copy home semantic folder app, and then the directory itself. Then the this these so the it will copy all the files from host computer to the container that are there in the app. Okay. Work dir. This instruction sets the working directory of the container, similar to the CD or Linux. Work dir, and that means the root itself, sets the roots of the file system in the container as a working directory. CMD. This instruction determines what command is run when the container starts. You would use this to start a service or application. CMD bin sh, and then the script -c script.sh. So this will basically run the command itself. Expose. This instruction is used to tell the person who runs the container what port they should publish when running the container. So expose 80 tells the person running the container to publish to the port 80. It will be like docker run -p8080. This is what we have used before, so no issues there. Now that we understand the code instructions that make up a Docker file, let's see a working example of a Docker file. But first, I will explain what I want the container to do. Use the Ubuntu version 22.04 operating system as the base. We'll use the tags here. Set the working directory to be the root of the container. Create the text file helloworld.txt. So they started with from Ubuntu. As you can see, we have used the colon and then 22.04. It will pull the image of that particular Ubuntu. And then we are setting the root as a working directory, and then we are running touch with hello world.txt. This will create basically hello world.txt only. Remember, the commands that you run via run instruction will depend upon the operating system you use in the from instruction. In this example, I have chosen Ubuntu. It's important to understand that the operating system used in the container are usually very minimal, and don't expect a command to be there from the start. Even commands like curl, ping may need to be installed. So this is a very basic minimal Docker image. It will not have a lot of commands that are available on the VM version of the OS. Building your first container. Once we have a Docker file, we can create an image using the docker build command. This command requires a few pieces of information. Whether or not you want to name the image yourself, we will use the t argument. The name that you are going to give to the image, the location of the Docker file you wish to build with. I'll put a scenario and then explain relevant commands. Let's say we want to build an image. Let's fill in the two required pieces of information listed above. First one is we are going to name it ourselves, so we are going to use the -t command argument. We want to name the image. The Docker file is located in our current working directory. The Docker file we are going to build is following: from Ubuntu, okay, as you can see, 22.04 working directory and run touch dot this one. The command would look like so: docker build -t and hello world and dot. We are using the dot to tell Docker to look in our current directory. If we have found out the command right, we will see Docker starting to build the image. So they have run the docker build -t hello world and then dot. So it is basically building the image itself, as you can see. Great, that looks like a success. Let's use docker image ls. So let's do this one first. Let me run this command. I'm not optimistic that this command will run on here, but let's see. Okay. Docker file path, the root Docker file, no such file or directory, as you can see here. So this command is not working for us, but it's working for them. Could it look like a success? Let's use docker image ls to now see if this image has been built. So you can see we have hello world in Ubuntu. Apologies, I'm feeling sleepy today. Note, whatever base operating system you list in the from instruction in the Docker file will also be downloaded. This is why we can see two images, hello world image and then the Ubuntu image, the base operating system used in our image. We will now be able to use this image in a container, referring to the running your first container task to remind you how to start a container. Leveling up our Docker file. Let's level up our Docker file. So far, our container will only create a file that's not very useful. In the following Docker file, doc file or Docker file, I'm going to use the Ubuntu 22.04 as the base operating system for the container. Install the Apache 2 on this web server. As you can see, they are running apt get update and y, and then they are trying to install the Apache 2-y and then exposing it on port 80. Add some networking. As this is a web server, we will need to be able to connect to the container over the network somehow. I will achieve this by using the expose instruction and telling the container to expose port 80. Tell the container to start the Apache 2 service at startup. Container do not have service managers like systemd. This is by design. It is bad practice to run multiple applications in the same container. For example, this container is for Apache 2 web server and the Apache 2 web server only. So this will particularly will work on with the Apache web server only. For reference, the command to build this would be docker build-t and then the web server and then the folder name. Assuming the Docker file is in the same directory as where you run the command from. Once starting the container with the appropriate option, the docker run -d --name web server, then the port we are exposing -p8080 and then the web server itself. We can navigate to the IP address of our local machine in our browser. Okay, optimizing our Docker file. So what is this, by the way? The web server works. Currently, Apache 2 is serving the default files because we have not added our own to the container. That is very correct. What else we have? Okay, we are very close. Optimizing our Docker file. There's certainly an art to Docker, and it does not stop with Docker files. Firstly, we need to ask ourselves, why is it essential to optimize our Docker file? Bloated Docker files are hard to read and maintain and often use a lot of unnecessary storage. For example, you can reduce the size of a Docker file or Docker image and reduce the build time using a few ways. Only installing the essential packages. What's nice about containers is that they are practically empty from get-go. We have complete freedom to decide what we want. Removing cached files such as apt cache or documentation. Instead, with tools, the code within a container will only be executed once or on build once, so we don't need to store anything for later use. Using minimal base operating system is our from instruction. Even though the operating systems of for containers such as Ubuntu are already pretty slim, consider using an even more stripped down version, which is Ubuntu, for example 22 and then dash and dash minimal as well. Or for example, using Alpine, which can be as small as 5.59 MB only. Minimizing the number of layers. I will explain this further below, no issues. Each instruction from run is run in its own layer. Layers increase build time. The objective is to have as few layers as possible. For example, try chaining command from run together like so. So they are saying before we were running everything on each command, and it will create a layer on top of the previous layer. But we can run all of this in just one straight line command. Okay. A terminal is showing 5 layers of Docker file being built. Why? Because we have 5 commands to run. After from Ubuntu latest, and then we combine all the commands that we need to run with AND operator. And what will it do? It will just build 2 stages here. As you can see, just 2 layers. Note here, how there are now only 2 build steps. This will be 2 layers, making the build much quicker. This is just a tiny example of the Docker file, so the build time will not be so drastic. But in much larger Docker files, reducing the number of layers will have a fantastic performance increase during the build. Okay, we'll take a look into that. Okay, what instruction would we use to specify what base image container should be used? I'm not sure really. The instruction must be placed at the start of the Docker file. Okay, from. Now I understand. Which instruction would you use to tell the container to run a command? Run. What Docker command would we use to build an image using a Docker file? Build, I think. Awesome. Let's say we want to name this image. What argument would we use? We want to name this image -n, or there was another one. Just a moment. These are the instruction. We can okay. You want to name the image yourself, use -t command. So we'll use -t. So scrolling down, -t. Hopefully this is the answer. Awesome. So we have done this. We are 36 minutes into the video. So once we come back, we'll go with tasks 5, 6, and 7. Thank you very much for joining me on this journey, guys. If you haven't subscribed, please subscribe. Give it a thumbs up. And if you have any comment, please mention it down below. And I will see you in the next video. Thank you. Bye.